Hello students, welcome to Engineering Guru. In this video we are going to learn about higher order linear differential equations, which is very important for the university exams, and this topic will be constituting of 15 marks. Now let's start. What is an nth order linear differential equation or higher order? So the standard form of nth order linear differential equation is given by d to the power ny by dx to the power n plus a1 into d to the power n minus 1y by dx to the power n minus 1 plus a2 into d to the power n minus 2y by dx to the power n minus 2 plus so on plus an minus 1 into dy by dx plus an into y is equals to q of x. So any differential equation of this form we call it as nth order linear differential equation. Now since the highest derivative is of nth order, so we call this equation as an nth order linear differential equation, where these a1, a2, a3 and so on an, they can be either constants or they can be either functions of independent variable. Now what is an independent variable here? So as the derivative is of the form dy by dx, so this y is the dependent variable and this x is independent variable. So if these a1, a2, a3 and so on, if they are functions of independent variable, that is x. Now if these values a1, a2, a3 and so on an, if they are constants, so then we call this equation as linear differential equation with constant coefficients. And if they are functions of independent variable, then we call this differential equation as linear differential equation with variable coefficients. In linear differential equation with constant coefficients, we are going to learn about yc, which is called as complementary function, and yp, this we call it as particular integral. And again, one more topic we are going to learn in this one is method of variation of parameters. And this is one of the most important topic which has been frequently asked in most of the university exams, and unless and until we don't know how to find out this yc, we can't solve the problems in method of variation of parameters. Now let's come back to this. If the a1, a2, a3 and so on an, if they are functions of independent variable, as we said, we call it as a linear differential equation with variable coefficients. And in this we are going to learn about Cauchy-Euler's differential equations and one more topic called as Legendre's differential equation. Now again, let's go back to our linear differential equation of nth order. Now it is of the form d to the power ny by dx to the power n so on an minus 1 into dy by dx plus an into y is equals to q of x, right? Now what I'll do is, instead of these derivatives, that means instead of d to the power n by dx to the power n, I'll be denoting this as capital D to the power n. So I'll put d to the power n by dx to the power n as capital D to the power n, and d to the power n minus 1 by dx to the power n minus 1, I'll write it as capital D to the power n minus 1, and so on. Similarly, d by dx denoting with capital D. Now if we substitute all these values in the nth order linear differential equation here, so then that equation will be of the form d to the power ny plus a1 into d to the power n minus 1y plus a2 into d to the power n minus 2y plus so on plus an minus 1 into dy plus an into y is equals to q of x. Now from each and every term, as we are having y, so I'll take out this y common. Then that will be of the form d to the power n plus a1 into d to the power n minus 1 plus a2 into d to the power n minus 2 plus so on plus an minus 1 into d plus an whole into y is equals to q of x. Now if we see the left hand side, now it is in the form of a polynomial in terms of d. So then I'll be denoting this as f of d into, here is y, is equals to q of x, and this we call it as generalized form of the nth order linear differential equation. So if we are saying f of d into y is equals to q of x, so these equations are again classified into two types. One is when q of x is equals to 0, and the other is when q of x is not equals to 0. Now when q of x is equals to 0, then the equation will be of the form f of d into y is equals to 0. And when q of x is not equals to 0, then the equation will be of the form f of d into y is equals to q of x. Now, when q of x is equals to 0, then we call this equation as homogeneous linear differential equation. And when q of x is not equals to 0, that is f of d into y equals to q of x, we call this equation as non-homogeneous linear differential equation. Okay, now let's discuss about the general solution for a non-homogeneous, that is f of d into y is equals to q of x is given by y is equals to yc plus yp, where yc we call it as complementary function, and this yc it is obtained from f of d, and in the same way yp we call it as particular integral, and this is obtained from q of x. Now what we are saying, the general solution for f of d into y is equals to q of x, we are saying it is y is equals to yc plus yp, where this yc is obtained from f of d and yp is obtained from q of x. So now if we discuss about this homogeneous linear differential equation, then the general solution for homogeneous linear differential equation will be y is equals to, as we are having f of d, we can get yc, but the value of q of x is 0, then yp does not exist. So then the general solution for homogeneous is y is equals to yc, and the general solution for non-homogeneous differential equation will be y is equals to yc plus yp. Why? Since we are having f of d, so yc will exist, and again q of x, so yp will be existing. So now, in order to find out this yc, we are having 5 methods, and in order to find yp, we are having again 5 methods. So total 10 methods we are going to learn, and it is very easy to learn this yc. Let's start discussing about yc. So that is methods of finding yc. Now, as I said, yc is obtained from f of d, right? So in order to find yc, first we'll be writing the characteristic or the auxiliary equation. So the auxiliary equation of the differential equation, let us say f of d into y is equals to q of x, is given by f of m is equals to 0. Say, for example, if I am having a differential equation as d square y by dx square plus 7 into dy by dx plus 12y is equals to, let us say we are having e to the power x. Now if we write this in a generalized form, now how to write it in a generalized form, as we discussed here, we are representing the d to the power n by dx to the power n. That means the nth derivative as capital D to the power n minus 1th derivative as capital D to the power n minus 1, and the first derivative, that is first order derivative d by dx as capital D. So then first we'll be writing it in a generalized form. So that means put d square by dx square as capital D square and d by dx as capital D. Now if we substitute these values in this equation, then that equation is of the form d square y plus 7 into dy plus 12y is equals to e to the power x. Now if we take out y common, that is d square plus 7d plus 12 into y is equals to e to the power x. So this is our required f of d and this is q of x. So that yc is obtained from f of d. Now in order to find yc, first we have to write the auxiliary equation, that is f of m is equals to 0. And it is very simple. Instead of d, put m. So the auxiliary equation of the given differential equation will be f of m is equals to 0. So instead of d, put m. Then that will be m square plus 7m plus 12 is equals to 0. Now, as it is a quadratic or it is a polynomial more precisely, so depending upon the roots of this characteristic equation or the auxiliary equation, we'll be writing this yc. Okay, now as we are saying, depending on the roots, so how many types of roots we are having? So as I said, in order to find yc, we are having 5 methods. Then depending upon the roots, that means we will be having 5 types of roots. Okay, now so depending upon the roots, so the first method is, or the first type is, like say if the roots are real and unequal. So real and unequal, say I am getting the roots as m1, m2, m3 and so on mn. Then yc is given by, so as we are having m number of roots, so in yc we have to put n number of arbitrary constants. So then the value of yc is given by c1 e to the power m1x plus c2 e to the power m2x plus c3 e to the power m3x plus so on plus cn e to the power mnx. Like say, for example, say if I am having the roots as m is equals to 3 and minus 5. So as we are having 2 roots, then we have to put 2 arbitrary constants in yc. Then yc is given by c1 e to the power 3x plus c2 e to the power minus 5x, as the roots are 3 and minus 5. Now in the same way, if I am taking the roots as 0, 3 and minus 2, let us say. Okay, so as we are having 3 roots, then we'll be writing yc as c1 e to the power 0x plus c2 e to the power 3x plus c3 e to the power minus 2x. Now since e power 0 is 1, then for this yc will be of the form c1 plus c2 e to the power 3x plus c3 e to the power minus 2x. So this will be the value of yc. Now in the same way, say if I am having the roots as, say if the roots are real and equal, say if the roots are real and equal, that is m1 is equals to m2 is equals to m3 is equals to so on is equals to mn, and say all these values are equals to m. Then the value of yc is given by c1 plus c2x plus c3x square plus so on plus cn x to the power n minus 1 into e to the power mx. Now why we are putting this x square and so on x to the power n? Why can't we write c1 plus c2 plus c3 so on plus cn? Now since, as we discussed, if there are n number of roots, in yc we have to put n number of constants. Now if I am not including this x square x to the power n minus 1, then it will be c1 plus c2 plus c3 plus so on plus cn. Now constant plus constant is again a constant. Like that, if we add all these n constants, you'll be getting only one constant. So in order to have the difference, we'll be multiplying with x, x square, and so on, x to the power n minus 1. Like say, for example, say if I'm having the roots as m is equals to 2, 2 and 2. Then as the roots are 3 which are equal, then we'll be writing yc as c1 plus c2x plus c3x square into e to the power 2x. And similarly, if I am having the roots as 1, 1, 2 and 4, if we see 1 is repeated only twice, so for 1, 1 we'll be writing for the repeated roots, so as c1 plus c2x into e to the power 1 into x. And again 2 and 4, they are real and unequal, so for them we'll be writing in the first type. Like so, c1 is over, c2 is over, then the remaining two constants, so that is c3 e to the power 2x plus c4 e to the power 4x. So this is the value of yc. Let's discuss about the third one. If the roots are complex conjugates. Complex conjugates. So complex conjugates are of the form m is equals to a plus or minus bi. If we are having complex conjugates, as there are two roots, one is with plus and another one with minus, that is a plus bi, and the other root will be a minus bi. We'll be writing yc as e to the power ax into c1 cos bx plus c2 sin bx. So this is the value of yc. For example, say if I am having m is equals to 2 plus or minus 3i. It is of the form a plus or minus bi. So the value of a is 2 and the value of b is 3. Then yc will be e to the power ax. So the value of a is 2, that is 2x, into c1 cos, the value of b is 3, that is 3x, plus c2 sin 3x. And again, if I am having the roots as m is equals to plus or minus 3i and 2 is there. So as plus or minus 3i, it is a complex conjugate and 2 is real number. So for complex conjugate, we'll be writing with the third type. So here the value of a is 0 and the value of b is 3. So then yc will be e to the power 0x. So e to the power 0x into c1 cos 3x plus c2 sin 3x plus, again this 2 is real, so for 2 we'll be writing it as c3 e to the power 2x. Now if we simplify this, as we know e to the power 0 is 1, so that is c1 cos 3x plus c2 sin 3x plus c3 e to the power 2x. So this will be the value of yc. The fourth type. So the fourth type is if the roots are equal complex conjugates. Equal complex conjugates. Okay. So that means m is equals to a plus or minus bi, and again it is repeated a plus or minus bi. We'll be writing yc as e to the power ax into c1 plus c2x into cos bx. So plus, again two constants are over, for the remaining again two constants, as we are having four roots, that is c3 plus c4x into sin bx. So this will be a value of yc. Like say for example, say if I am having m is equals to plus or minus 2i and plus or minus 2i. So here in this case the value of a is 0 and the value of b is 2. The value of yc will be e to the power 0, which is 1, c1 plus c2x into cos b, that is 2x, plus c3 plus c4x into sine 2x. So this is the required value of yc. The last type, that is the fifth type, that we call them as conjugate surds. So conjugate surds will be of the form, they are irrational numbers, that is a plus or minus root b. Say if the roots are of this form. Now we can write this yc in two different ways. One way of writing it is c1 e to the power, as they are irrational numbers which are again a part of real numbers. So as we discussed in the first method, as they are real numbers and they are unequal, then one way of writing is c1 e to the power m1x plus c2 e to the power m2x. So c1 e to the power a plus root b into x plus c2 e to the power a minus root b into x. Or another way of writing this yc is e to the power ax into c1 cos hyperbolic root bx plus c2 sine hyperbolic root b into x. So this is the value of yc. Now we have discussed the first method. What is the first method? Discussed about yc's. So if the roots are real and unequal, then the value of yc is given by c1 e to the power m1x plus c2 e to the power m2x plus so on plus cn e to the power mnx. Now in the same way, if the roots are real and they are equal, say all are equal to the number m, then the yc is written as c1 plus c2x plus c3x square plus so on plus cnx to the power n minus 1 into e to the power mx. And in the same way, if the roots are complex conjugates, that is they'll be of the form a plus or minus bi, then yc is given by e to the power ax into c1 cos bx plus c2 sine bx. And we have seen the examples of these three types also. And in the same way, say if the roots are equal complex conjugates, so that means if the roots are of the form a plus or minus bi and a plus or minus bi, then the value of yc will be e to the power ax into c1 plus c2x cos bx plus c3 plus c4x sine bx. The fifth type, if the roots are conjugate surds, that means they are irrational numbers of the form a plus or minus root b. So there are two ways of writing this. So that is c1 e to the power a plus root b into x plus c2 into e to the power a minus root b into x. And the other way of writing this is e to the power ax into c1 cos hyperbolic root bx plus c2 sine hyperbolic root bx. And the same problems or the same methods and or the types all are given in the PDF format. Thank you.